Hey guys, it's Andrei here, and today I thought I would have a little bit of a different video. So, if you are new to my channel, I usually do gaming videos. I've been doing playthroughs where I play some spooky games, and my sister's been helping me. Sometimes she's the one playing the games. I plan to do like other games with my friends. I also like to do fencing videos for like tournaments, and I have like a stretch routine coming out soon. But today I wanted to do a programming course series, and I wanted to do the first episode today. As you guys know, I work as a software developer in Spark Cognition, an AI company, and yeah, I thought I could do like a programming series, start from the basics, and then work our way up. Um, so let's look at what we have here. I made everything pretty big, so I hope that you guys can look look at the code. Okay, I'm going to upload this to my GitHub, and I'll put the URL in the description video so you guys can just download it and look at it. But the other day I found a Manila folder showing or like containing a bunch of competitive programming problems. I used to compete in my school's competitive programming team in high school, and then took some classes at UT. So yeah, I decided I wanted to get back into it. So let's look at our first problem today. Today we're gonna go over the basics. It's not super advanced. So yeah, let's get into it. So what I wanted to do today to kind of warm up, and we're gonna be using Python. I am using Python 3.95. I wanted to look at the Fibonacci sequence. So I have here my sample code. And let me know in the comments if the text is too small, too big. I'm still messing with it. We can delete this. But if we look at the Fibonacci sequence, it's a very famous sequence. It's a bunch of numbers. The first few numbers go like this: 5, 8, 13. And this is more like an intro video. Maybe you're new to programming and you want to learn Python. I might be doing C#, some other languages as well, C++. But today we're doing Python and Fibonacci. So it's a sequence of numbers. It's an infinite sequence. And it's a series, I guess. And it continues, right? So those are the first few numbers. So if we look at the numbers, the nth number, it's really defined by, so let's look at this too. It is the addition of the previous number and like the number 2 spots before it. So 2 is equal to 1 plus 1. So for instance, like f of 4 is equal to f of 3, which is a 1, plus f of 2, which is another 1. So that is equal to 2. And then if we look at the fifth element, so there's 3, that is equal to f of 4, which happens to be a 2, plus f of 3, which happens to be a 1, and that's equal to 3, and it goes on and on. So we can describe this series as f of the nth element is equal to the nth minus 1 item, I guess, plus the n minus 2 item, right? And link to here, there we go, the link to the Fibonacci number sequence, and you can look at it, and it's very special because it's based on the golden spiral, and it's in Wikipedia. I can also add the link if you guys want, and if you want to learn more about the math behind it. So let's say that we're in Python, right? And you're given the problem that you have to solve this, maybe in a in a sample coding interview, very basic, or maybe in class, or you just want to learn, right? It's a very common programming problem. So how can we approach this? Well, so as a more experienced programmer, right? Like it obviously, today I'm gonna keep it very basic, but I want to show a few methods to do this, and some methods are better than others. So we can write our sequence, our Fibonacci sequence, right? and this is going to be our function, and then we're going to return something, right? So first, let's say we get the input from the user. We ask them to calculate which number they want to calculate. So then we can say like x is equal to input. The user will put in the input, and then we can say like n. So we kind of cast this as an integer, right? Convert the string or a number to an integer is possible. I should say I am using Notepad++ as my IDE. It's pretty good, and Python 3.9 as I showed before. I think Notepad++ is a very basic IDE. It's great for just like random scripting like this. Other than that, I would recommend Visual Studio. So it's really good, especially if you do C++, C#, which is kind of what I do. And then this is going to be like here, we're going to have our output. So let's say fib of n, right? And then maybe we want to print fib of n, and maybe we want to have a list. Let's say we want to print maybe like some numbers, right? So we can say like fib nums is equal to I for I in I for range. So we want to do n plus 1 because range is not inclusive, and rather than I, we would do like fib of I. And I can explain this in more detail in a sec. And then, okay, so let's get to the basic naive. So this is going to be the naive solution. And you can guess from the title, it's not the best. So we're assuming, right, I'm not validating the input, the user. I'm just expecting, I'm testing it, and I know they're going to provide an integer representation in a string. But just for good practice, we can check, because the sequence, it starts at the 0, so these items are defined, and then the first like 2 or 3, the first three items are defined, and then you use the sequence to compute any element after that. But let's say that if n is less than 0, maybe we print like invalid number, can only input positive, and maybe we return like a -1 or something. Okay, now if they provide the 0 element, we want to return 0, right? If they provide this element, or if they provide the first or second element, we return 1. Okay, so now let's say, what if they provide the 10th element? How can we compute this? And this is kind of where you have to be thinking about this critically. But luckily for us, we have a series, right? A lot of times when you're programming, it's important to be able to write down in paper or like plan out how the code is going to work, and then you actually start programming. So I would do this in paper, and then once I figure out the series, how to do, then we can code it. So the nth element is equal to, and we're using recursion here, right? The n-1 element plus the n-2 element. And f is our function, which we have defined here. And let's see if this works. We can just run Python fib. Oh man, I need to switch to my, one sec. I need to switch to this path. I wonder if I can, I'll just do it. Sorry about that. Okay, so let's input our number, and number 5. And then 5. So we look at the fifth element, 0, 1, 2, 3, 4, 5. We're starting to count from 0, it is 5. Let's look at the let's say the 10th element, 55, which is the addition of those two. Okay, so now let's look at the, let's say, 20th element. Okay, pretty good, pretty efficient, right? So what happens if we look at the 40th element? Oh, it's slowing down, it's thinking. I'm actually gonna let it run while I talk. I might stop it if it takes too long. So what is happening? So we notice this solution is slow. So, I mean, this is just the series, right? Why is it slow? Well, let's look at what's really happening. We want to compute the f of 20, right? Okay, so it finished. So it was that, I would say that was pretty slow. Okay, so we want to compute the 20th, or in this case, the 40th element. Let's just say the 20th element for simplicity. Okay, so how do we do that? Well, we compute the f of n minus 1, so that would be f of 19, plus f of 18, a n minus 2 element, right? Okay, well, we don't know what these are, right? So we need to compute them as well. So f of 19 is really f of 18 plus f of 17, right? This is f of 19 inside the brackets. And then f of 18 is really f of 17 plus f of 16. So what can we notice here? By computing f of 19, we're going to be computing f of 18 and f of 17. By computing f of 18, we're going to be computing f of 17 and f of 16. So first of all, we are duplicating computations, right? And you can see by computing f of 19, we computed f of 18. So we're duplicating these computations here as well. And this is just going to propagate all the way down because we don't know what f of 18 is. We only know really what those values are, 0, 1, and 1. So f of 0, f of 1, and f of 2. So we have to divide this f of 18 into 17 and 16, 16 and 15, 16 and 15, 15, 14. So you can see every step we get times 2 the number of computations, but then they're repeated. So this is very, very inefficient. We don't want to do this. This is, I mean, the simple solution, it works, but it's very inefficient. So let's try. How can we address this? Okay. How can we address this? If you're at home and you're following along this tutorial, I know I'm going super fast. You can also feel free to like pause and try to figure it out on your own, and then watch the video to see the solution. So I'm now gonna do a more efficient method. So why don't you stop now in 3, 2, 1, pause, and then try to figure out the video. And if you got a solution that's more efficient, congrats, very well. I think you're on your way to learning some programming. If not, that's okay. We're gonna work through it. So let's see. So we want something that's faster. What are some ideas? If you had some ideas on how to make this more efficient, please comment down below. But an idea that comes to mind is to build up, right? Build our solution up. Okay, I'm gonna get some water. So in here, we're working down and we're repeating computations. So if I knew what f of 18 was, or here, for instance, let's say I knew what f of 17 was, I wouldn't have to compute those two values. And then because f of 17 is going to be f of 16 and f of 15, if I knew what f of 16 was, I wouldn't have to compute it inside it, right? So maybe we have to work our way up, kind of like we do in the sequence. So let's call this build Fibonacci. And we're gonna, if they give us a negative number, we do the same thing, right? Okay. Oh, okay, and then I didn't actually show this, so I wanted to show how we can do a list. Let's say we do a Fibonacci, right? And we pass in the first, and we wanted to compute the first 5 numbers, right? This is what this is computing. So it's a loop, and I'm looping from I at 1 in the range, or I guess in the range 0 to n plus 1, non-inclusive. So it's the number 0 to n, and then sorry about that, and then I am computing the values of Fibonacci, so then I create the list, so we can create like the first 10 numbers. The 10th element 55, and the first 10 numbers are 55. So this is what this is. Okay, so now I will put 2. Actually, we'll just do n for now. Okay. So maybe in here we can have a list, right? And we can define Fibonacci, the Fibonacci values. So we can say fib nums. 0, 1. We don't want to use fib because that would just call this function. It would be all sorts of problems. Okay. Fib nums 0, 1, 1, 1. The first 3 elements, right? And then we can say if okay. So let's say we want to compute the 3rd element. So the 3. How would we do that? Well, fib actually we can optimize this a little bit. We'll just say 1. Okay, so let's say we want to compute the 2nd element, so 0, 1, 2, so this 1. We would start at the range 1, and we're going to loop from 2, so that which is going to be the next number that we append, from 2 to, because remember range is not inclusive, n plus 1, and we're going to append to our list. And then we just want to return the element, so we're going to slice it. Okay, so let me explain this a little bit. Kind of went through this a little fast. This is a list containing the first elements, 0 and 1. And then after that, we say, okay, starting at the 2nd element, we're going to start computing from the 2nd element to the nth element that you give us, n plus 1, because range is not inclusive, so you kind of want to add 1 element, so you loop through it. And we say, okay, so the next element, so fib nums of 2, like the 3rd element, is just the previous 2 elements added together. So let's see if this works. So let's say 10 numbers. So let's just add a print statement here so we know. Build Fibonacci. Print naive Fibonacci. Okay, let's try again. I mean, it worked, but we'll show naive Fibonacci. We'll just there we go. Okay. Boom. Spaced out, right? Looks nice and pretty. Naive Fibonacci, the first 10 elements are this, and the 10th element's 55. Pretty good. So last time we did 40, naive Fibonacci could not handle it. So let's comment this out. Notepad++, you can use Control-K to comment out stuff. Pretty fun. Let's try if this can handle the 40th element. And boom! Just like that, we got it, right? It's, yeah, it's a really good function. We could actually even make it return the entire list. And then we could look at the elements independently. But yeah, pretty quick, right? So it's faster, it's building up, but even then, if we go too far away, it's not the best, because every time, let's say I want to compute Fibonacci of 40 and then Fibonacci of 39. So the answers, it got them pretty quick because the number's not that big. But what's happening is I'm building up and computing all the numbers from 1 to 40 and then storing that in this list, and then I return the sliced element. So I'm indexing here into the 40th element. So I make a list of 40 items and then I return the 40th element. Then I do it again for the 39 items. So what can we do here? Take a moment and think to yourself, how can we improve this? Because it's clearly not ideal, because I'm recomputing the entire list twice. Like if I computed the 40th element, I should already know what the 39th element is, right? Okay, so let's look at so we're going to have this function. So in competitive programming, in dynamic programming, and just programming in general, there's something called memoization. So you're like, memoization, what is that? Well, memoization is a technique where if you compute a very expensive function, you only compute it once, and then the values are saved, and you don't have to compute it again. So I'm going to show you. So this is build up, it's faster, but we compute every time. Okay, so memoization. So we save the values for next time, for other operations, other times. We'll say other times. Right. So with this technique, if I compute the entire list with the first 40 elements, and then I want to get the 39th element, it's going to be saved and it's just going to return. Because let me show you. I guess I could print the list here so you see how it grows. About indentation. Okay. So if we want to compute the 5th element, this is our list looks like. The first time 0, 1, 1. Second time we added that new element, new element, and then we are done in the for loop, and then we printed the final value. So we don't need this, and then let's say, okay, so what if we want to do n-1 and n-2? So let's say like 5 is good. So the first time, compute all the values, print. Then n-1, compute all the values, print, and then compute all the values, print. So clearly this is not ideal. We are recomputing all this, right? So this is when memoization comes into play. So we are going to pass in fibnums. Actually, we're going to be using a dictionary. Very fast insertion and deletion. Of course, we keep this if they input a bad value. And then we pass in n. So we want to compute the nth element, right? So if n is not in our current dictionary, fibnums, then we're going to make the key. So this is using recursion as well. but we're caching the values into this dictionary. So this is a dictionary. If our current value, so let's say our value 0, our key is 0, value 0, key 1, value 1, the next would be key 1 or key 2, value 1, and then it would be key 3, value 2, and then key 4, value 3. So the key is the index, right? So if n, let's say the third value, is not in our dictionary, which is not, we compute this by calling our function recursively. So by the way, if you don't know recursion, then this might be a little bit too advanced. I should have said that at the beginning, where I used recursion here. I might have another video. If you guys don't know about recursion, add it in the comments, and I can make another video where I explain head or tail recursion and different things, right? So we call our own function with the previous values. So n minus 1, our key is going to be now 1, and then n minus 2, our key is going to be 0. We have those values. So then we just return the value of our key. Sorry, no. And yeah, let's see. The 5th value. Okay. Let's see the 10th value. 20th value. Okay, what about the 40th value? Yeah, seems pretty good. So you might be thinking, okay, it was really just as fast as build Fibonacci. If anything, if you only compute the value once, one value, they're pretty much identical in speed. Build Fibonacci might actually be faster because you're not using recursion, you're simply doing a list and appending and operations. But let me show you why this is good. I'm doing basic print statements. I'm not like formatting strings and stuff, but so you can see how our list is building. It's printing because of the different stacks. But you can see at the end we have computed our list. And to make it easier, I'll just print the very final value. No, actually, no, I'll keep it. Yeah. We are computing and building our list, right? And then once we get here, it's all cached. So the next time when I compute the previous element, our list is already created, so we can instantly see the 4th element, key 4, is 3. So if we do like, so this is when this comes in. We pay the expensive price once, but after that, it's really good. With n minus 2, I'll just print the final list, so it's not as cluttered. Okay, so we are modifying our list 1 1 because that's what we start out, and it's 2 recursive calls, and then it's moving up the ranks, right, as we compute values. And then the first time, you know, it's pretty expensive. We pay the price, and we get our final list, and this is the 20th element. But what if we want the 19th element? Well, it's already computed. As you can see from our list, we don't have to modify it. We don't have to do the recursive steps, right? And then boom, we just get it. And then n minus 2, any value before, we can get. And if we wanted to do like n plus 1, right, we've already computed most of it. Actually, I think 40 was too much, too hard to say. We'll do like 20. Yeah, the same value. So when we do, so this is what we did before. When we do n plus 1, so this is our previous list, and then we just compute from it the next values. So we do it once because we've already done all the hard work before, and then boom, it's ready. Right? So that is why memoization is good. You only pay the expensive price once. Now, this is also not ideal, because we are using recursion here. The only benefit of the other one is to, and you can like even combine this, right? You can combine memoization into here by having this list be shared. You could pass it in. It would be better. Right, to build it up and then keep the list. You can combine these two. Maybe I'll do on the next video on that or something else. Like a build-up list that you keep, because the issue with this is because it is recursion. If you do a really big number, like 10 million, we're going to run out of depth because of recursion. But yeah, I think of course, like, these are different solutions, they all work. There's a better solution with in-place addition. Maybe I can do a part 2 or in depth. And then there's actually an even better solution. So this was not a video about finding the optimal Fibonacci sequence solving solution, right? Because there really is a mathematical formula that uses the square root of 5 and a power. You raise to a power and then divide by the square root of 5, and it gives you the value. And it's like super quick and no recursion. This was more of a showing you how there can be multiple solutions to the same problem, and there might be different drawbacks or cons and pros associated with every solution, right? And like a naive solution might work, but then maybe you need to make it a little bit better. So bonus, we can try, and like you didn't have to use a dictionary here, I just chose to, right? List, dictionary, kind of show different skills that you guys can work with. More of a tutorial video. So let me show you, let me show you a better solution than this, because this uses recursion, which is not ideal. So we'll say memoization improved. We'll just use a dictionary because it's nice and easy. And this solution, I wasn't gonna do it, but I decided why not. We'll just do it. So it's kind of a build, fib, and so we're going to be trying to use this idea, but be storing a memoization, right? Implementing memoization. So we get our list, which is going to be our dictionary pre-populated, and then but we're going to be working from the bottom up instead of using recursion, right? There we go. Yeah, gotta be careful with your indentations. Key error. Oh, of course. Boom. So 20. Let's see what's happening here. So we computed all the numbers up to 20. And then once. And next time we wanted the 19. Right, I'll showcase the differences. And of course it was this one. So the first one is right here. We compute the values, right? We work all the way up to 55. Oh, this is the one showing recursion. Okay. And it looks, this one will work pretty similar, right? But the issue was that it stacked recursion. The second one, we created a list. Want this value, right? We return it. Then we want the previous value. Our list is already created. We return it, and then just expand our list. So the first one, if we do like 1,000,000, let's start with like 10,000. It runs out of recursion depth, right? Oh, I guess I should have. Let's only print one, because printing I/O takes a lot of time. Okay, I'm just commenting out the other test cases. I just want to show you one number. So this is 10,000. Boom, got it, and it's pretty fast, right? If we do 10,001. So let's do like 1,000,000. Now that it takes a long time. And for that, there's another better solution, and there's a formula. But like I said, this is just different techniques, right? I wanted to showcase recursion a little bit, how you can use lists, maybe using dictionaries, memoization, and how to improve it a little bit without recursion, right? So we're not running out of the stack trace. Yeah, I'm just gonna stop it. So yeah, let me know if you had any trouble, if you could figure it out on your own. Hopefully text was fine, and yeah, enjoy. You're now a programmer. And stay tuned. I am planning on releasing more videos where I continue to play Alien Isolation. That one's in Spanish. And then my sister, where she plays Hello Neighbor. We might do some other games. And I want to do a video where I share my stretch routine that I do every day, a 20-minute routine, great for you. So stay tuned for more, and comment down below if you like this, if you what you want to see next. I'm gonna be doing competitive programming problems, and if like the text size and everything is good. All right, stay tuned.